Is it recording? Okay. So section 7, topic 1. And it's called the Remainder Theorem. Okay, remember how when we learned how to do long division of polynomials, we learned that shortcut method? Y'all remember that at all? Yes, Miss Rayleigh? Okay, good, because we got to do that again today. So in my first example, I'm going to take x squared plus 3x minus 10, and I'm going to divide it by x plus 5. So we learned how to divide this using long division, and we also learned how to divide it using synthetic division. And today we're going to use synthetic division. So I'm going to rewrite this where it looks like a long division problem, and you don't have to do this step, but for the sake of notes, we're going to do it. And remember, whatever this number is, you're going to change the sign. Okay, so since that's a positive 5, we're going to make it a negative 5 and put it behind that little house thing. And then you're going to bring down the coefficient of every term under or in the dividend. And remember, if you're missing a term, you have to put in a 0 for a placeholder. So we have 2 degrees, 1 degree, 0 degrees. So are we missing any terms? No. So for x squared, there's a coefficient of 1. We'll bring that down. Positive 3 and a negative 10. And then remember, we skip a line and draw a line. Y'all remember this? No? Okay. So the first term, you just drop down below the line. And then you take that number and you multiply by whatever was behind the little house. So 1 times negative 5 is negative 5. In this step, you just add or subtract. Whatever the sign is, that's what you do. So I have a positive 3 and a negative 5. Make what? Negative 2. Then we multiply all over again. What's negative 2 times negative 5? Positive 10. Then add or subtract whatever the signs say. A negative 10 plus 10 is 0. So then, this is not my answer. 1, negative 2, and 0 is not my answer. I need some x's in there. So go back to your dividend. If it has a degree of 2, we go 1 below that. So whatever the degrees are, you take 1 from that. So instead of x squared, this will be 1x, and then you just go down in degrees. So that's 1 degree, this is going to be 0 degrees, and this is going to be your remainder. So your answer is x minus 2. So what happens is, the reason that we're using division in this section when we've already learned how to do synthetic division, when you divide and you get a remainder of 0, what that tells us is that what we came up with, the quotient and the divisor, are factors of x squared plus 3x minus 10. So if we were to factor this, which we are going to, so I can show you, if we were to factor with a t-chart and divide and slide, we would see that x plus 5 is a factor and x minus 2 is a factor. If you get a remainder that's any number other than 0, then they're not factors, okay? And this is helpful because, does Mr. Brown ever come in this class? No. Whatever class he has, I think it's 7th period he always comes in. And he's like, have you showed him how to do division yet? Because this is one way, especially if it's not a quadratic, because we know how to factor those. But if we get like a polynomial with higher degrees, and we don't know how to factor it, you can use division to help to see if you can find some factors. Okay, so that's what we're getting at. But let me show you how to factor, not how, you know how to factor, x squared plus 3x minus 10, so that you can see that we actually, x minus 2 is a factor and x plus 5 is a factor. So, is there a greatest common factor? Nope. And it is a quadratic, so if it's factorable, we'll use the t-chart and divide and slide. What's A? 1. What's B? 3. And what's C? Negative 10. I need two numbers that multiply together to give me A times C, which A times C is negative 10, and add to get B, which is positive 3. Y'all have any ideas? Alright, 5 times negative 2 is negative 10, and 5 plus negative 2 is positive 3. So that works. So in your parentheses, you'll have x plus 5 and x minus 2. So, what I set up here was, if you divide and you get a remainder of 0, then that lets you know that the quotient, that's the answer you get when you divide, the quotient and the divisor, that's what you're dividing by, are factors of the dividend. Okay? So that's the title of this section, is the remainder theorem. That's what the remainder theorem says. It says if the remainder is 0, then the divisor and the quotient are factors of the dividend. Write that down below. If the remainder is 0, then the divisor and the quotient are factors of the dividend. Everybody cool with that so far? Okay, page 137. Find the remainder of the quotient of m of x and n of x, comma, where m of x equals x cubed minus 7x minus 6 and n of x equals x minus 4. So we're dividing that, they just wrote it weird, okay? So we're dividing m of x divided by n of x. Remember, you can only use the synthetic division if your divisor is linear, okay? If it's quadratic or cubic or quartic or quintic or sextic or septic or octic, can't remember all the words, octic or decic, you can't use the synthetic division. It's only if this is linear, okay? Otherwise, you have to do it the long way. Either way, am I missing any terms under in the division, in the quotient? How many degrees up? 3, 1, 0. Am I missing any? 2. So I'm going to have to put in a placeholder for 2 degrees. So that the x cubed, doesn't matter if you add or subtract 0x squared, because it's 0, minus 7x minus 6. So remember, when you're doing synthetic division, your divisor, you want to change the sign of that number. So we'll put a plus 4 behind our little house. Bring down the coefficient of every term. So the coefficient of x cubed is 1. We have a 0, a negative 7, and a negative 6. Skip a line, draw a line. So to start, the first number you just bring down. And then what do? Multiply. 1 times 4 is 4. Now we add or subtract. It just depends on the signs of the numbers. So we have 0 and a positive 4 make positive 4. Then what? Multiply again. 4 times 4 is a positive 16. And what's a negative 7 plus 16? Positive 9. Now we multiply again. 9 times 4 is positive 36. Negative 36, I'm sorry, negative 6 plus 36 is positive 30. Now we stop multiplying because we don't have any more numbers, right? So in my quotient, what's going to be the highest degree? The first term is going to have how many degrees? 2. Because if this has 3 degrees, then we just go 1 below that. So my answer will be 1x squared plus 4x plus 9. Once we get to 0 degrees, if there's another number, it's our remainder. So is x minus 4 a factor? No. Is x squared plus 4x plus 9 a factor? No. If this was 0, then it would be a factor. Okay? Now, what I'm going to show you now is we can figure out what the remainder is going to be without having to do the division. Okay? So we can figure out a lot faster if these are going to be factors or if they're not going to be factors, because all you need to know is the remainder. That's all you need. So what you do is you evaluate the dividend by whatever that number is that you put behind the house. Okay? So you're going to evaluate x cubed minus 7x minus 6 at m of 4. And I used m because that's the function that x cubed minus 7x minus 6 was. 4 because that's the number that we put behind the little house. Okay? So if we just substitute 4 into that function for x and evaluate, we're automatically going to know what the remainder is. So let me show you. So that would be 4 cubed minus 7 times 4 minus 6. What's 4 cubed? 64. Negative 7 times positive 4, negative 28, minus 6. And we get 30. So, see, that's what our remainder was, and that'll work every time. So we'll know just like that, is this a factor or is it not, okay? We have a question on that? Okay, let's do another one. Page 138. Find the quotient of a of x and b of x comma, where a of x equals x to the fourth minus x cubed minus 3x squared plus 4x minus 1, and b of x equals x minus 1. So it's asking me to use division. So x minus 1 is my divisor. And my dividend is function a. Am I missing any terms? Nope. So what am I going to put behind the house? Can y'all hear me today? Nobody's answering me. So what am I going to put behind the house? Thank you. 1. Change the sign of the number in the divisor, the constant. We said we weren't missing any terms here, so just take the coefficient. So I have a 1, negative 1, negative 3, positive 4, and negative 1. Skip a line and draw a line. First number, you just bring it down. Multiply. Positive 1 times positive 1 is positive 1. Add and subtract. Negative 1 plus 1 is 0. 0 times 1 is 0. Negative 3 plus 0 is negative 3. Negative 3 times 1 is negative 3. 4 minus 3 is 1. 1 times 1 is 1. Negative 1 plus 1 is 0. Is x minus 1 a factor? Yes, it is. And whatever we have left, the quotient is also going to be a factor. Okay? So we have 1x squared, or not x squared, x cubed, 1 degree less, plus 0x squared minus 3x plus 1, remainder 0. So x minus 1 and x cubed minus 3x plus 1 are both factors of x to the fourth minus x cubed minus 3x squared plus 4x minus 1, because the remainder is 0. So let's just see if when we substitute 1 into function A, let's see if when we substitute that in, if we will also get 0. Okay? So let's find A of 1. And wherever I see an x, I'm going to substitute in a 1. Bless you. So 1 to the fourth is 1. I'm not cubing this negative sign. I'm only cubing the 1. 1 cubed is 1. And with that negative, it makes it negative 1. 1 squared is 1 times negative 3 is negative 3. 4 times 1 is 4. Bring down the minus 1. So left to right, 1 minus 1 is 0. 0 minus 3 is negative 3. Negative 3 plus 4 is positive 1. 1 minus 1 is 0. Which is what we got when we did long division. So again, x minus 1 is a factor, and x cubed minus 3x plus 1 are also factors, all of the dividend. Are we okay with that? Okay, so I want you to try one. Is x minus 4 a factor of 2x cubed minus 3x squared minus 18x minus 8? You tell me. I'm just going to sit here quietly. Anybody got the answer yet? It is? Did y'all get it is? Remainder of 0? Did you use long division or did you just substitute in a positive 4? Long division? Okay. I like long division too. To me, it takes less time than substituting it in. I guess it depends on how long the problem is. I'm also going to use long division. Am I missing any degrees? 3, 2, 1, 0. I'm not. So bring down a 2, a negative 3, a negative 18, and a negative 8, and put a positive 4 behind a little house. Drop the 2. 2 times 4 is positive 8. Negative 3 plus 8 is positive 5. 5 times 4 is positive 20. Negative 18 plus 20 is positive 2. 2 times 4 is positive 8. Negative 8 plus 8 is 0. So that's my remainder. I have 2x squared plus 5x plus 2, remainder 0. So yes, x minus 4 is a factor. And so is 2x squared plus 5x plus 2. But it just said, is x minus 4 a factor? Now on the next page, I'm going to show you how this is helpful when you're factoring one of these polynomials with bigger degrees. Because do we know how to factor function A? Is it a quadratic where we can use t-chart and divide and slide? No. Is it a difference of squares? No. Is it a difference of cubes? No. Is it a sum of cubes? No. Is it one of those quartics that we can rewrite as a quadratic? No, well, it's a quartic, but it has to rewrite it as a quadratic. It has to be 4 degrees, 2 degrees, 0 degrees. And we have 4, 3, 2, 1, 0. So that won't work. Can I factor by grouping? No, I can only do that with 4 terms. Do we know how to factor this? No. But we did just find that x minus 4 is a factor. Okay? We know it's a factor. And 2x squared plus 5x plus 2 is a factor. Now, this factor is linear. It can't be factored any further. But this factor is a quadratic. Is it possible that we can factor that further? Okay, so let's do that on the next page. Are y'all awake today? No? I didn't think so. So, since x minus 4 and 2x squared plus 5x plus 2 are factors, we can try to factor 2x squared plus 5x plus 2 using divide and slide. So A is 2, B is 5, and C is 2. Make a little t-chart. You need two numbers that multiply together to give you A times C, which is positive 4, and then add together to give you B, which is positive 5. Y'all have any ideas? 4 and 1? 4 times 1 is 4. 4 plus 1 is 5. Got it. So make your parentheses. And you'll have x plus 4 in one set and x plus 1 in the other. Am I finished factoring? Is my first term times my first term my first term? Nope. Is my last term times my last term my last term? Nope. What have I not done? Divide and slide, because A is a number other than 1. So we have to divide or slide. 4/2, is that going to be a divide or a slide? A divide, because 4 divides by 2 evenly, right? So it gives me x plus 2. 1/2, divide or slide? That's right, kids, slide. And when you slide, if you can reduce first, you have to. Can you reduce? No, you can't, kids. That's right. So we'll just slide it on over, and I get 2x plus 1. So my first term times my first term, x times 2x is 2x squared. And my last term times my last term is my last term. So that's just a quick check. Okay, if something's wrong there, we know we definitely did something wrong. If those are right, then we probably factored it correctly. And we did. So remember, we already had x minus 4 as a factor, and we took the quadratic and factored it further. So we have 3 factors. Oh, I didn't mean that. I didn't mean the factors of 2x squared. I meant the original. What'd y'all tell me? Sorry. I meant the factors of 2x cubed minus 3x squared minus 18x minus 8. Sorry about that. Can I factor any of those any further? Nope, they're all linear, right? And as long as they don't have a GCF, they can't be factored further. If I were graphing this, what would my end behavior be? Y'all just took that test. Most of you did really good on that part. We already forget? Or are you just still not talking to me today? Down and up, thank you. And how many solutions would you have? 3. 3 degrees, 3 solutions, right? What solution will we get from x minus 4? Y'all are killing me. If I set that equal to 0, well, 4 and negative 2 and negative 1/2, right? So that's where it will cross the x-axis. Coolio? Let's do one more, then I'll give you your homework. Well, more like classwork. All right, let's determine if the binomial x minus 4 is a factor of the polynomial x cubed plus x squared minus 16x minus 16. Period. If it is, then completely factor the polynomial. So if it is, I'm going to have to factor it anyway, so I'm just going to use long division so I know. If I substitute in the positive 4 and I get 0, I'm still going to have to do the long division to see what I have left, right? So I might as well just go ahead and do the long division. And I'm not missing any degrees. So I'm going to change the sign of -4, bring down a +4, and then a coefficient of each term. So 1, 1, -16, -16. Skip a line, draw a line. My first term, just bring it down. 1 times 4 is 4. A +1 and a +4 make a +5. 5 times 4 is +20. -16 plus 20 is +4. 4 times 4 is +16. -16 plus 16 is 0. So my remainder is 0, so is x minus 4 a factor? Yes, Miss Riley. So it says if it is, then completely factor the polynomial. So x minus 4 is a factor, and then this will be 1x squared plus 5x plus 4. X squared plus 5x plus 4 is a factor. But that's a quadratic, so we might be able to factor that further. X minus 4 is linear. The only way you can factor a linear polynomial is if it has a GCF, okay? So x minus 4 is a factor, but we're going to see if we can factor the quadratic further. Does that make sense? So we know A is 1, B is 5, C is 4. We need two numbers that multiply together to give us A times C, which is +4, and add together to give us B, which is +5. Didn't we just factor a problem like this? It's 1 and 4. I think that was what it was on the last one. 1 times 4 is 4. 1 plus 4 is 5. We'll have x plus 1 and x plus 4. Do we need to divide and slide? Nope, because A is 1. So the factors of x squared plus 5x plus 4 are x plus 1 and x plus 4. It wants to know the factors of x cubed plus x squared minus 16x minus 16, right? So the factors are, don't forget the x minus 4, that was our divisor. We're not going to use x squared plus 5x plus 4 because we factored it further. So we're going to use the factors of x squared plus 5x plus 4. We have x minus 4, x plus 1, and x plus 4. So if we multiplied all that out, we would get x cubed plus x squared minus 16x minus 16. Everybody cool with that? You have any questions?